how not to count polygons. In this puzzle, you have to count polygons whose vertices lie on 7 points. Here are the points. Let's take a typical example. This one here, it has 7 points, so this is a heptagon, and you have to count all possible polygons. How on earth are you going to do that? Well, first of all, let's say thank you to the website that I found this on. It is Don Stewart's website called Median, so you can Google that. I am really impressed with this website. It's a practical resource for teachers like few others. To find other people that I respect, you can always go on the inspired section of Math Pickles. You can just, Math Pickle is my website, you can just go to Inspired People, and you can see here some of the people that I think are real leaders, both past and present, in mathematics education. Okay, so we have 7 points in this heptagon, and we're happy with that. Let's now look at a 6-sided figure. This is a hexagon. Are there any other hexagons that we need to count? Sure, here's another one. There's a concave one and another concave one. In fact, there's a whole bunch of concave ones. Here's a pentagon, another pentagon, and you can see that counting these is going to take your students a good deal of organization. And here are the quadrilaterals. Okay, and the triangles. Finally, the triangles. Okay, so here we go. There are your first attempts at counting. And what do you say to a student that says, "This is the answer"? Well, you might show them another student's work, and another student might say, "Well, that's pretty good, but haven't you forgotten over here I see that equilateral triangle, but that's a different size from that equilateral triangle." So the second student says, "Well, those are different. The scale is different, so you have to count both of them. Yes, I know that they're the same shape, but they're different, so I have to add that one." So the other student wasn't complete. So you can see that a student might argue that. Are we complete? Well, just when we thought we were, a third student comes up, and the third student says, "Well, I just had pizza yesterday, and the pizza slice looked very much like that. And I can tell you that it makes a big difference if the pizza is this way facing on my plate or this way. So I can't flip these shapes over. And so just the same as my pizza, I can't flip that triangle over. So let's see, this does look different from that. I think it is a different piece of pizza. Okay, so I need to count both of those. They're not the same." You can see the way that student was thinking. Okay, and the same is true for this pentagon, is it? Do we have to count the mirror image or not? Well, let's see. The mirror image of that pentagon is that yellow shape, and sure enough, if I flip it, I can get to that shape, but also I can get to that shape just with rotating. So actually, I do not need to include that shape. So see the triangle there, the student would say, "Well, I need to count both of those triangles because I can't get from one to the other without flipping." But for this pentagon up here, the student correctly did not place the mirror image of that pentagon, because all that he had to do was to rotate his plate. If he got a piece of pizza in that shape, all he had to do was to rotate his plate around. He didn't have to flip it over so that the cheese side was down. Okay, but there are some shapes here that there is no way to get at them without flipping, just like that triangle on the left side. Where are they? Here they are. There's 4 of them. So those 4 shapes, you cannot get to them by just rotating your plate. You have to pick them up and flip them over. So we want to count both of those. So let's do this, and we'll zoom down now. Let's flip them all. 1, 2, 3, 4. Here, finally, our third student has come up with a solution that looks complete. But then a fourth student comes up, and the fourth student says, hey, look over there at that heptagon. Well, that heptagon isn't the same if I rotate it a little bit. Okay, that's like a Pac-Man eating up here versus eating down here. They're all different. You can't say that they're the same, so we have to count each one of those polygons. Oh, well, that might be true, but that's going to create a lot of problems because all of those have got 6 different possible orientations that we would need to take into account. So that's going to make our table huge. So the student might be right, but you just might want to say, you go and do that for homework and come back next week. Okay, so I'm not going to consider that now. And you could see that you could also have combinations. So you could have a student that says, flipping, I'm going to allow that, but I'm not going to allow rotation. So you could have any combination of these. The important thing is that you get your students to start talking about their assumptions before they start tackling into making this definitive grid of the solution, because they're going to come up with different solutions. Okay, another student might say, you know what, you guys have only considered polygons that don't intersect with themselves. Those are called simple polygons. But actually, I'm going to count complex polygons. Well, if you thought that we were in trouble before, that's going to create a lot of mess. So I'm just going to count the complex quadrilaterals. That is, all of the quadrilaterals that have the property that at least 2 of the edges intersect with each other. You might want to turn off this video and try to count them all. Okay, here I'm going. So that's the first one. There's the second. I'm pushing that dot to the back in the middle there. There's the third, the fourth, and the fifth. I think that's them all. Oh, no, there's the sixth. Okay, good. Here you can imagine that we've counted all of the complex polygons, but we have allowed for rotations and we have allowed for flipping and for scaling. So the triangles, we only have 3 triangles. So we're not, in one sense, we're not as complete as that second student and third student. But in another sense, we've made different assumptions that allow us to count things that those students hadn't considered. So this one, counting simple and complex polygons. So the motto of this little story is to get your students talking among themselves before they go about trying to construct a grid and trying to count complex objects.